Now the third question says, Peter has more money than John. If Peter gives John $15, they would have the same amount, while John gives Peter $20. Peter would have twice as much as John. How much does each one actually have? So solution. So first what we need to define is x and y parameters. So let's say x is the amount Peter has and y will be the amount John has. So this is John. So from here we can see that if Peter has, or rather, if Peter gives John $15, so this is Peter losing $15 to John, they would have the same amount. Okay, John gains $15 from Peter. So they have the same amount, and this is equation one. And the second statement says, or the third statement rather, while if John gives Peter $20, okay, Peter has $20, Peter would have twice as much as John. So Peter will have twice as much as what is remaining with John because John gave Peter $20. So this is what will be remaining. So Peter will have twice as much as this, and this is our equation 2. Now I can rewrite my equation 1 by saying that x minus y is equal to 30, and I can rewrite my equation 2 by opening this bracket saying x plus 20, this is equation 1 still, x plus 20 is equal to 2y minus 40, and this will give me x minus 2y is equal to negative 60, and this is my equation 2. So I can solve by either elimination method or by substitution, but let me solve by elimination method. Okay, now this is my equation 1 is 30, this is my equation 2 negative 60. Now if I try to eliminate x, which is the easy variable to eliminate, I will put my negative signs here. So x minus x, that has been eliminated, is cancelled. Y negative y, negative negative 2y. So this becomes positive, and I will have here negative y, positive 2y, and here I will have 30, negative negative 60. So this becomes y, because negative y plus 2y becomes y, and this becomes 90. So my y is 90, or rather $90 for John here. So what about Peter? Now if I impute the y value into my equation 1, which is x minus y equal to 30, I will have that x minus 90 is equal to 30, leaving with x equal to 30 plus 90, and that leaves me with 120. So $120 for Peter. Now let's see if this is correct. From the first statement here, we are meant to understand that Peter gives John a sum of $15, and both of them have the same amount. So if Peter is giving John a sum of $15, John will receive $15, and we know that Peter has $120 minus 15, and we know that John has $90. So plus $15. So this leaves Peter with $105. And this makes John have a total sum of $105. So this actually agrees with the state first equation here, which is the second statement, while our answer agrees with the first statement, which says that Peter has more money than John. We can see 120 and 90. So for the second statement here, we are meant to understand that Peter gives, John rather gives Peter $20. So if John gives Peter $20, we know that Peter is X plus 20, that Peter will have twice as much as what is remaining with John, and we know that Peter already has $120 and is giving $20 to from John, and John will be left with $90 minus 20 because he gave out 20, and this gives us 70 here too. And we can see that this actually works because 120 plus 20 gives us 140, and we can see that Peter has twice as what is left because 2 times 70 will give us 140. So Peter has twice as much as John. And this statement is also correct. Now we move to the fourth question here. And in the fourth question, we have that in a two-digit number, the unit digit is thrice a tens digit. If 36 is added to the number, that is the two-digit number, the digits interchange their place. Find the number. Okay, solution. Now, the two-digit number is x and y, and I can rewrite it as 10x plus y, where x is equal to the tens digit and y is equal to the unit digit. So we are meant to understand that the unit digit is thrice the tens digit. The unit digit is y and it is thrice the tens digit. So if 36 added to the number, this number, 10x plus y plus 36, the digits interchange their place. Instead of being xy, it becomes yx. And we are going to find the number. So here, our y is now the tens digit, so it can be rewritten as 10y plus x, where y is now the tens digit and x in this case is now the unit digit. So we can see that we have two equations here. This is first equation, and 10x plus y plus 36 is equal to 10y plus x, and this is our second equation. Okay, we can see that we already know our value for y. So if I impute y value into equation 2, I'll have that 10x plus y value, which is 3x, plus 36 is equal to 10y, and our y is 3x plus x. This leaves me with 13x plus 36, which is equal to 10 times 3x, which is equal to 30x plus x. So 13x plus 36 is equal to 31x, because 30x plus x is 31x. So I can rewrite this as 31x minus 13x is equal to 36. What I just did was to take my 13x above the equality sign, becomes a negative 13x. So 31x minus 13x, we have 18x equal to 36. So my x is equal to 36 divided by 18, which is 2. Now, for the first two-digit number, which is this, my x is 2. Now, if I impute this 2, impute the value of x into equation 1, which we can see here, I will have that y is equal to 3x. This is my equation 1. So y is equal to 3 times 2, which is 6. So y is equal to 6. Now let's see if we are correct. Okay, from the first statement here, we are meant to understand that x and y, or rather from our answer, we are meant to understand that x and y is 26. Okay, and here we are told that if 36 is added to the number, the digits interchange their place. So this is our 26. So if 26, which is this number, if 36 rather is added to this 26, we should have an interchange number, and it is actually true because the 26 plus 36 is 62, and you can see that this 62 is equivalent to what we have here, which is yx, and this is correct. So this is the correct answer.